In our fourth and final part of our basic trig review, we are going to find side lengths and angle measures on right triangles using sine, cosine, and tangent, as well as special right triangles. So here we are looking for this side. We have an angle right here that's 51 degrees. Across the triangle, that is the opposite leg. And right next to this angle, that is the adjacent leg. So we're going to use SohCahToa. So we've got opposite leg and adjacent leg, O and A. That comes after T for tangent. So we're using tangent 51 degrees equals opposite over adjacent. Opposite 15.9 over adjacent x. When I have a variable in the denominator here, I like to use the property of proportions that says I can switch elements diagonally at any time. So x is 15.9 divided by tangent 51 degrees. So 15.9 divided by tangent 51 is 12.88. Here's my angle. Across the triangle, I have the opposite leg, and here I have the hypotenuse. Opposite leg and hypotenuse right here, O and H. That means I'm using sine. Sine 38 degrees equals the opposite leg, x, over the hypotenuse, 2. When the variable is in the denominator, I like to cross multiply. So I have x times 1. This is really over 1. So x times 1 equals 2 times sine 38 degrees. 2 times sine 38 degrees is 1.23. Here's my angle, and what I have here is the adjacent leg, and here is the hypotenuse. Adjacent and hypotenuse, A and H, means I'm going to use cosine. Cosine theta equals adjacent leg 9 over hypotenuse 10. This time the variable is the angle, the input, and when the variable is here as the input, I use an inverse. So theta equals inverse cosine, 9 over 10. Second, for inverse cosine, 9 over 10 is 25.84. So theta is 25.84. And because this is an angle measure, I want degrees. Next, we have a 30-60-90 triangle and a 45-45-90 triangle. I'm going to walk through this using shortcuts, and then I'm going to use some more math to solve. So if you like shortcuts, this first way will be the easier way. So in a 30-60-90 triangle, I know that the hypotenuse is exactly double the short leg. So I could say y is 20 root 2. 20 times the square root of 2. I also know that in a 45-45-90, if I take one of the legs and multiply it by the square root of 2, I get x, which means x is 20 times the square root of 2 times the square root of 2, which is 20 times the square root of 4. But I do need to simplify this because the square root of 4 is 2. So really this is 20 times 2. So x is 40. Okay, so that's a shortcut way. Now I'm going to show using proportions. So on a 30-60-90, I like to put on the numbers 1, 2, square root of 3. So the shortest leg is 1. The hypotenuse is the longest, that's 2, and the remaining side is square root of 3. Now what I'm looking for here is y, and I'm going to use what I have here to write a proportion. Y is to 2, as 10 times the square root of 2 is to 1. And all I have to do is multiply that 2 across, and I get y equals 20 times the square root of 2 over 1, but I don't need to write over 1. Okay, so I can write here, this is 20 times the square root of 2. Now, on a 45, 45, 90, the numbers are 1, 1, and square root of 2. So x is to the square root of 2, as 20 times the square root of 2 is to 1. So I multiply the square root of 2 across, and I get 1 times x, which is x, and 20 times the square root of 2 times the square root of 2. Square root of 2 times the square root of 2 is the square root of 4, or 2, so it's 20 times 2, so x is 40. And last, we have a ladder 552 centimeters long leaning against a building. Okay, so we have the ground, here's our building, here's our ladder at 552 centimeters. If the angle between the ground and the ladder is 63 degrees, so 63 degrees, how far from the wall is the bottom of the ladder? Please forgive my grammar here, that should be a comma and a lowercase h. So I want to know the distance from the wall to the bottom of the ladder, so that's right here. And we'll round this to the nearest tenth. So here's my angle. Here I have the adjacent leg, and here I have the hypotenuse. Adjacent leg and hypotenuse, A and H, are cosine. So we have cosine 63 degrees equals the adjacent x over the hypotenuse 552. And here I'll cross multiply, so this is really over 1, so I have x times 1, and then 552 times cosine 63 degrees. So 552 cosine 63 is 250.60, so 250.6 to the nearest tenth, 250.6 centimeters.